In this video, we're looking at the standard definition and standard forms of the equation of a parabola depending on how you're given. Now, it's important to understand that these forms, they could show up in two different ways. What's unfortunate about that is that there's then two different ways a parabola could be seen. A parabola could be seen to have a vertical axis of symmetry. Like the last example we did, that means it's going to look something either like this, or it's going to be upside down like this. So this first type of equation looks something like this. Again, it has a vertical axis of symmetry. So the equation for this is going to be some form of x squared. Now keep in mind that we're working with systems such that the vertex has h comma k, so it's x minus h quantity squared. Again, if it's facing vertically, that means our x has to be squared, and that's going to be equal to 4 times p times y minus k. So this is the equation of a parabola in standard form where the axis of symmetry is vertical, or another way to phrase this is that it's opening vertically. So in this case, the axis of symmetry, it being a vertical value, has to be x equals, in this case, the h. Again, how far it's been shifted left or right. Your focus, in this case, again, keep in mind you're always going to take your focus value and whatever the 4p sits with, in this case, because it's sitting with the y value, you're going to add it to the y value of the vertex. So my vertex being h comma k in this problem tells me that it's going to be h comma k plus p. Again, it's important to understand that the h comma k is stationary, it's not changing, but then when we try to shift the focus from the vertex, we're going to add that distance value of p. My directrix, however, is going to be similar but slightly different. The directrix, keep in mind, is an equation of a line, and it must be perpendicular to that of the axis of symmetry. So in this case, it's going to be a y equals line, and it's going to be p units from the vertex still. So we're still going to have k as our starting position, but now we're going to go ahead and shift p units. But the problem is that, remember, the focus is one direction, the directrix is the other. So you're always going to subtract that p value from that directrix y value for this type of equation. Now, if we shift it down, we're looking at a horizontal axis of symmetry for the second set of equations. So this changes things slightly, but again, keep in mind we're going to retain the vertex of h comma k. Now, what's important to really grasp and really sink in here is that this is the x value and this is the y value of the vertex, x, y. So when I write out my equation and we're looking at a horizontal axis of symmetry, meaning that we're not looking at a function, we're looking at an equation of a parabola. This is defined differently, so we're not trying to dense it down into a function. We're trying to call it an equation. So it's going to look either like this or like this. So the equation is actually going to have these two details swapped. And when I say these two details, I mean that instead of having the x squared, you're going to have the y squared. But keep in mind that the k retains, the y when moved retains that minus k with it, because the k is the y value in that vertex. This is now equal to 4 times p times, in this case, x minus h. Now, before I move too far forward, the understanding of this entire section focuses on the idea that p is a distance. If you can solve for that value of p, then you technically have all the answers you need. It also ends up becoming that this section really just focuses on a bunch of different formulas and minor rules. The horizontal axis of symmetry is going to be passing through the y value of the vertex. So in this case, it's going to be a y equals to k value. Again, just like this was x equals to h with the square term, this is y equals to k, the square term. So now our focus is still going to be h comma k to start. However, again, h comma k to start. However, we're now going to add the p value to the x term. Again, the p sits with the x term, so the p is going to be added to the x term to find that new focus. So my x term starts off at h, and I'm going to add the value of p to it, comma, don't forget k. Focus is still a point, so I need to make sure I identify that point. My directrix, however, is again going to be, in this case, a vertical line. So it's going to be an x equals line. This time starting at h again still, but this time we're also going to, just like we did up here, we did k plus p. For the directrix, we did k minus p. So we did h plus p in the focus. We're going to do h minus p in the directrix. So this is the list of all of the rules that we need for parabolas. It does show itself in a formula sheet in some way or another, but if you can identify whether or not the x term is squared or the y term is squared, based on maybe which way the graph is facing, it might also help you vice versa and backwards. And then all you have to do is just make sure you get 4p. If it's not an actual 4p, maybe it's something like 18, well, you can go ahead and get 4p and set it equal to 18 and solve for p. Getting that, we'll just be able to use these two things like formulas, and the same goes for down here. So this is really the setup again, and all possible equations for this, and in the next video we'll go ahead and do a few more examples.